Hey, good morning, everyone. Welcome to session 2 of day 2. Today's webinar is Security Design Strategies for the Age of BYO. Hello, I'm Tyler, and I'm your moderator for today's presentation. During the webinar, you may submit questions for the presenter at any time using the questions pane of the control panel. You may send these into your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Now, please welcome Wolfgang Gerlich.
Hey, thanks so much. And thanks everyone for joining today. Security design, this is what we're looking at. You know, there's a lot of conversation about where security needs to go in terms of human factors. And what I'm going to be covering today is a very tangible framework for having these conversations, thinking through these challenges, and I'll give a couple of different examples. As mentioned, I am Wolf Gorlick. I am an advisory CISO with Duo Security, the multi-factor and zero trust company. And my focus is very heavily on the front end of IAM, right? MFA, passwordless, certainly single sign-on, adaptive and contextual authentication, all those types of challenges are things that I spend a lot of time looking at. And previously, I led IT and IT security in the healthcare and financial services verticals at a hospital and a money management firm, respectively. Clearly, you don't get to be a gray beard in this field without making lots of mistakes. So a lot of the times when I've stumbled, a lot of the times when I thought things were going right and they weren't, I've thought through quite a bit recently as I've tried to figure out different strategies that we can do for security. But first, let's look back, right? 2020, let's look at the past decade, where we were and how we got here. A lot has changed. Obviously, one, the internet is the new network, and it works. That sounds surprising, perhaps. I'm surprised at how well, frankly, the internet is working right now with all the shifts we've seen. But certainly, anyone who's building a service, anyone who's launching an application, what are we looking at? We're looking at how do we deliver that over the internet to people working from anywhere at any time on pretty much anything. The BYO of the conversation in terms of networking. The cloud is the new data center. So no one builds data centers anymore. It's kind of sad. I'm looking forward to retiring and building data centers and turning milk into butter and blacksmithing and doing all those great hands-on skills. At the beginning of the last decade, I was responsible for a couple of data centers, one of which I built, and of course now it's all cloud, right? I mean, we've radically changed since AWS launched in 2006 and Azure launched in 2010. The average enterprise today has over 1,400 cloud apps that are in use. The average power user, and a power user is about 1 in 5 of our employees, the average power user is using 36 cloud apps on any given week. And meanwhile, in security, we're usually securing like 40. So there's a big delta going on there. But clearly, everything has moved to cloud apps. Everything has moved to BYOD. Before last decade, there wasn't even a BYOD term that didn't even come out really until Intel adopted it in 2011. It's hard to imagine that, right? It's hard to think back to the time where I was issuing my end users pagers and BlackBerries. And then they all got off the BlackBerries. I'm like, guys, stay with me. Stay with the BlackBerry. It's got a keyboard. I can lock it down. But no, they all wanted their iPhones. So, of course, BYOD is the new stack. iPhone came out. iPad came out in 2010. iPhone a little bit before that. And today, power users, 1 in 5 of our employees are using 6 or more devices. So the concept of BYOD, bring your own device, singular, is even gone. Even that's changed. Now it's devices as we try to manage all the different things people come in with. Average employees are using a little bit over 2, in case you're curious. And sadly, the breach is the new security. With all these changes, we are, as an industry, of course, scrambling to catch up. scrambling to address this rapid shift that we faced. But it's only gotten harder because the bad guys have only gotten more funding. In 2015, cybercrime became more profitable than drug trade. Last year, business email compromise brought in 10 times the profit of robbing a bank, which is just ludicrous. When I'm building data centers, I like to think that criminals are going to go back to robbing banks. Just, again, old-fashioned, kindler, gentler, simpler times. And in 2011, right, we had around 1,300 data breaches with around 400 million records. And we thought that was crazy. We thought that was an insane amount, and everyone was going to wake up and things were going to get better. But by 2019, we had 5,000 data breaches. So from 1,300 to 5,000. And now the number of records, of course, are in the billions being lost. So that is a look back at the last decade. And hey, welcome to 2020. No, I mean seriously, welcome to to 2020. Obviously, we're all dealing with some significant shifts in the way we work. Previous to March, the statistic I saw for United States, previous to March, was 15% of the people in organizations working from home. At the end of March, due to lockdowns, due to everything else, I'm in Michigan. We've been in shelter in place now. I think we're going on week 5. It all kind of is a blur. At the end of March, that number had reached 78%. Now it's coming back down. It's coming back down as states start to open up and things change. But certainly this radical shift has only accelerated trends in terms of moving to the cloud, only accelerated trends in terms of providing security from anywhere to anything. Anytime someone is accessing something from somewhere, it's certainly created some very unique challenges. So that is the backdrop to which everything else hangs on, right? So I'm gonna talk about some design strategies to address this rapid shift. But I do think we need to just take a moment and appreciate the very exciting times to which we live in. So much of this talk is going to be comparing, security to industrial design. I think we can learn a lot from industrial design. I do want to give a shout out to Uncomfortable, which I believe took, in my mind, is what would happen if we took security principles and moved them into design, right? Via chairs you can't sit on, via the concrete yet very secure umbrella, the handles that don't quite fit. It is a very good, I think, visual representation of how hard it is for many of our users to use the technologies we provide them. So the slide transitions in this talk are coming from the Uncomfortable, so shout out to them. This is the latest in my design series of talks. I have looked at this from a big picture. Is design a problem? Spoiler alert, it is. I've looked at this from an applications perspective. Can we use design to create apps that lead our end users to better secure decisions? Again, spoiler alert, we can. As a matter of fact, looking at what Dual has done over the years is a phenomenal case study in how to use design to nudge users to make better security decisions. I say this why? Because if you're interested in the topic and exploring further, you can head up to my YouTube and catch a couple of those videos, or of course, tweet at me or follow my blog, because I'm constantly thinking about this and I would love to have conversations afterwards. So this got its start when my wife gave me this book called Design of Everyday Things. And I think she regrets it, because I'll come downstairs like I did the other day and I'm like, honey, did you know Levi Strauss has a mad scientist of jeans, and here's what he did, and here's how we redesigned jeans, and here's the problem they face, and she just sort of nods her head, and I'm sure she's absolutely tired of me doing that. But as I'm flipping through this book about a year ago now, I came across this statement: most industrial accidents are caused by human error. Estimates range from 75 to 95%. How is it so many people can be incompetent? And I just heard about Gartner's figure of 75 to 95% of cloud breaches are caused by, user mistakes. I'm like, yes, tell me, Don Norman, why is it so many people are incompetent? So I flipped the page, and he writes, answer, they aren't. It's a design problem. I'm like, don't you do that to me, Don Norman. Don't you tell me it's my problem. Don't you tell me it's on us. We know it's the users. They don't do the right thing. Why are they incompetent? But this really started me down this path of looking at security as a design problem. And I think it's a fresh lens that we don't often use. And I would argue today, and I'll demonstrate in a couple of examples, that it can lead to some novel implementations of security. Now, Don Norman was obsessed with the teapot, hence the cover. One more shout out to the uncomfortable and their absolutely unusable teapot, which if you don't have the matching cup is guaranteed to spill tea everywhere. And if you do have the matching cup, perfect, it's guaranteed to spill tea all over you. Much like a lot of the security solutions we ask people to do every single day. So let's talk about levels and life cycles. Let's look at how to design security. This is the framework I mentioned that we'll tease apart throughout this talk. Excuse me. First off, let's say we want to design a security capability. A security capability is some people, some technology. Let's see, what's a good example? Identity access management for this example. We will talk about identity access management, right? What happens when we hire somebody? We want to make sure they have permissions right away. What happens when they move to a new job? We want to make sure they get those permissions, but don't aggregate permissions over their lifetime. What happens when they leave the company or are invited to add value elsewhere, as they say? We want to make sure that their access is removed very quickly so we don't have an insider threat. Security capability. Now, the nature of so many of us is to jump right to the tools. Why? Because that's where we came from, right? That's what's exciting. I got into security so I could get hands-on with things, so I could build things and break things, so I could look at people trying to break my stuff and I could defend it, so I could, have a game of cat and mouse, have a game of Risk. I want to play with the tech. And I think that is what leads us to the concrete umbrellas. So I would put forward the life cycle of design looks like this. What's the vision? Our vision here is that employees can get appropriate amount of access and do their jobs without getting in the way while protecting the organization. What does it mean for the business? It's so absolutely vital that we in security secure the organization by protecting the technology that enables the organization to achieve its mission, certainly, but there's also trade-offs there that I think can sometimes be overlooked. For example, I'm advising a company, and we are looking at pen testing. So I introduced them this pen tester. He's phenomenal. He is a one-man show. He's absolutely brilliant. He can walk through walls. He's a ghost, and they loved him. But then I go, wait a minute. The reason why we're getting a pen test is not only to protect the technology, but to demonstrate to our investors, to demonstrate to our customers that we have done the right thing. They don't know who this guy is. So we really need to go with more of a marquee name so that it is furthering the business benefit of protecting the investment and growing customers and everything else. It's a business trade-off. Now, purely from a technical perspective, go with a ninja. But if you're looking at it from the perspective of protecting the organization by protecting the technology, that decision makes sense. So we look at the business side of things. I am getting people to work very quickly so they're not sitting around. That's usually where the start is. We start thinking about the security capabilities. How does this thing that we're building tie in with everything else we do? How is it going to tie into monitoring? How's it going to tie into our threat intelligence program? How's it going to tie into our insider threat program, right? How's it going to be reported up? So we start thinking about the security capability sides of things. Then we get to the specific controls. Hey, least privilege all day long. Segregation of duties all day long. Access reviews and access certifications, right? All those controls that tie back to compliance standards and tie back to things like the CIS, critical security controls, and the cybersecurity framework, those sort of things. Then and only then do we get to the tooling, and then we build a great implementation plan. So maybe we're saying, hey, we're going to use Microsoft for our, directory service. We're going to use SailPoint for our IGA. We're going to use whatever the tooling may be. But by that point in time, we've aligned it with everything else within the organization. I think from a design perspective, that's what's really critical, that we follow a set methodology, a life cycle for designing, and then we act at different levels to make the best decisions possible. Certainly the CSO is going to be more on the business and the security level. Certainly the security frontline practitioner is going to be on the tooling level and the implementation level. It is, though, the realization that we need to look at each one of these levels and follow life cycle to really get the full value of the security capability. When I was a security officer, I used to call this the Four Horsemen. My guys hated it, but I'm like, hey, before we buy any tool, I want to see the security done in PowerPoint. I want to see it done in Word. I want to see it done in Excel, and I want to then and only then think about the tool. I'm a big fan of Excel. I think you can do a lot with Excel. And what this boils down to is have the vision, have the policy procedure, have some metrics that are tracking the program, and then and only then start putting in the automation and everything else. I think way too oftentimes we love our tools, we're excited about our tools, we want to get hands-on, we jump right to that point, and that is what creates the situation where we've got a misalignment with the people who are going to be actually living and breathing in this environment that we're creating. So, second thing, I think it is important that we remember that we are in effect doing two things at once. We're going in two directions. We are thinking about defensibility while we're thinking about usability. It's blurring of those two that creates issues. We want to design those security capabilities that get in the way of the adversary, but at the same time, we want to design security that gets out of the way of the end user. So how do we do that? There's a couple different things that we can think about. We obviously want to think about our users. They're all happy. They're all excited. Never have I had users that look like this, but I can hope, right? I've still got a few years in my career. And then, of course, we want to understand our adversaries. We want to do threat modeling. We want to inform that with threat intelligence. We want to understand what their motivations are, what the personas of the adversaries are, where they're going, the path they're taking, so that we can do something about it. A good example of doing both of these things is the iPhone with Touch ID. So back to my BlackBerry. I really, truly did love my BlackBerry. And I love my BlackBerry Enterprise server because I could make everyone have a passcode. And then, of course, consumerization happens, bring your own everything happens, people start getting iPhones. I'm like, guys, don't you realize these phones have keyboards and encryption? They're like, I don't care. And what we saw was that less than 20% of consumer devices had passcodes. No one had passcodes. As a matter of fact, Steve Jobs, who had many rants, many rants of Steve Jobs, had a rant about how we shouldn't even have passcodes because it's getting in the way of, the creativity and the experience of the iPhone. So when designers were coming up with the next release, the next version, they looked at how people were using it. People would pick up their phone, they hit the home button, and then they browse around, right? It's the normal thing that we do 1,000,001 times a day. I've got screen time on my phone, which I should have never done. And it's like, oh, you pick up your phone every 10 minutes. I'm like, yes, I do. So you hit the home button. So what they thought was, hey, wait a minute. What if we were to give a better experience, use that exact same experience, but inject a security control that doesn't add any steps to the user, vis-a-vis the thumbprint reader on the home button? Okay, now what if we were to use choice architecture, smart defaults, to encourage people to enroll, vis-a-vis setup that enrolls your thumbprint, right? What they saw was within a year of the phone being released, people locking the phone jumped to over 80%, from under 20 to over 80. In 1 year. Why? Because it wasn't any additional steps. It was a simple choice to make. And what did that mean for the attacker? That meant that criminals could no longer just pick up their phone and browse through it. And the adversary here is not necessarily like a criminal stealing your phone. It's generally more like a nosy kid, a nosy relative, someone in your house, someone you're dating, right? People you don't necessarily want to be browsing your pictures. So I think that's a great example of good design leading to better security. The point I want to make here is that we're all creating experiences, either intentionally with the security controls we put in place, or accidentally by putting the wrong controls in place, jumping straight to tooling, or not thinking about defensibility. Right? How oftentimes have we looked at a pen test report and went, oh, you went from this server to that server, or that over to there, and then you got Kerberos ticket, and then your DA, and then you flipped over the table. Okay, good. This is the path we've created. This is the experience we built for the pen testers, unintentionally, with how we've set up our networks. So either intentionally or accidentally, we're creating experiences. So we need to think about designing better experiences. And there's two parts to that. One is thinking about the paths they take. And they, I mean, both the user and the adversary. A good area for research for this is the study of wayfinding. The second is the choices they make, right? A good area of study around this area is like choice architecture and decision the psychology of decision making. So for the choices they make, we want to optimize things like the number of steps. Fewer is better for usability. The familiarity of each step. When work looks like work, work gets done. If it's familiar and you're used to it, it's easy to do. When it's not, it's a problem. I get very frustrated the one time every 4 to 6 weeks I need to log into my VPN. Why? Because there's more steps and I'm not used to it. And I probably have to update it, which adds friction. So these are the three areas to consider for a path perspective. From a choices perspective, it's the number of choices they make. It's the predictability of each choice. If I choose A, I'm going to get B. If I'm sure in that prediction, making the choice is very simple. If I'm not sure, things get more creative. I'm more tentative. I take more time to think about it. And time is something we want to play with from an adversary perspective. If I can make an attacker slow down and think through very carefully whether or not they use PowerShell Empire or some other exploit to get into my network because I've mixed up the path they're taking, that buys my monitoring, my SOC, my IR team time to detect and respond and get them out. And finally, it's the cognitive load of the choice. The more we ask for people, the less they want to engage. And that can be a problem with users, or that can be a very good thing from an attacker perspective. So what happens when this doesn't happen, when we don't think through these things? Well, one, users just bypass whatever controls we put in place. They don't follow the path that we want them to. The more constraints we put on a user, constraints is measured by controls. The more constraints we put on a user, the more creative the user becomes, creative constraint theory. The more creative the user becomes, the more dangerous the user becomes to our security. Why? Because they work around it. This is what drove consumerization last decade in BYO everything, because you didn't have any controls. This is what drives cloud SaaS apps. Why? Because it's easier for me just to provision it, get my data on there, go to work, then bring in the security team who wants to do a whole bunch of stuff. It's very important that we not constrain users to the best of our abilities. And the flip side, of course, is if we've not thought through these things and made a more difficult path, made choices more difficult, the attacker oftentimes has a clear path into whatever they are going for. If the attacker's going for cheese, it's a clear path to cheese. If we've got everything on the internet and it's unpatched and it's open, it's Elasticsearch and S3 and every breach ever for the past year, every single day. So let's give a couple examples of this in play. One, the first one I want to look at is passwords. Passwords have been around for longer than many of us have been alive. For the past few decades, passwords have been the single factor, the first and last line of security. And of course, we know passwords suck. They're easy to forget. They're easy to share. They're easy to reuse. On and on and on and on. So What is passwordless? So let's start with multi-factor authentication. I know everyone on this call gets this, but this makes passwordless that much easier. Right? You throw in your password and you add a factor. Maybe it's push on your phone. Maybe it's SMS code that's texted. Maybe it's a biometric. Maybe it's Touch ID all over again. Whatever it may be, you have a password and that additional factor. And adding that additional factor has increased the number of steps for the user, right? It's increased the number of steps. It may increase the friction depending on how that factor is implemented. It may increase or decrease the familiarity. So for example, push all day long, I love it. There's about, I don't know, maybe 4 or 5 systems I go into where I've got to use a different authenticator because they're texting me or because it only uses this other authenticator in my phone. And so the push is not in the same direction or not in the same spot, or I've got to browse for it, or I got to copy a code. And pretty quickly I start getting frustrated, even though it's still multi-factor, right? The familiarity starts causing frustration. So it definitely has done something for users. But what has it done for the attacker? That one additional factor has effectively stopped in its tracks the majority of attackers who use and reuse stolen creds. Google had a study out where they showed after they enabled MFA that account taker fell down to 0%. 0%. It's unheard of. Now, certainly as more people are using the factor, it's going to be more familiar for the attackers, and there's going to be more ways and work done to try and bypass it, steal codes. Absolutely. But still very strong control and a good example of adding to a user that also adds to the attacker, but has a disproportionate impact on the attacker. So that's multi-factor. Passwordless is as simple as removing the password. A lot of times I talk about passwordless and people go right to biometrics. I blogged about passwordless recently and people are immediately like, well, wait a minute, what about my fingerprints? I'm like, look, I was very careful in my blog to not mention biometrics because one of the things I think is interesting about passwordless is not only the biometrics, but also all these other factors we've used over the years, figuring out which factor makes the most sense for the security use case. So people log in now with biometrics. People log in with a push. People log in with, there's a Azure login right now with SMS codes. And they do that without any passwords in, done, which is a much better user experience. On phones, which arguably, pioneered this concept, of course, Touch ID, I already mentioned, Face ID, and the Android world, the fingerprint API. On desktops, certainly Mac, Touch ID, and Windows Hello. Windows Hello is a really intriguing way to go ahead and implement this as well. You walk up, it looks at you, you're in. On the web side, the FIDO2 protocol stack, WebAuthn, CTAP, are making it possible to consume Touch ID, Face ID, Windows Hello, etc., and pass that into a web browser. So same exact experience on the web application side. So really cool stuff going on. Now, what's intriguing about this is back to my point about design, balancing defensibility and usability. If I'm typing in a password, there really is no way for the keyboard to know if it's me. Now, someone can go ahead and tweet me, yeah, but there's this and that and the other, because there's a couple different edge cases, but really there's no different. I can't make a better keyboard that makes it harder for the bad guy to type in the password. However, when the early biometrics around facial recognition were compromised, very quickly the camera manufacturers came out with anti-spoofing technology. As a matter of fact, if you're playing with Windows Hello or have it, double check and make sure you've got the anti-spoofing features enabled. It's a group policy setting. So the anti-spoofing comes out, right? Now that fingerprints are starting to be broken on Touch ID, there's some research you can read about this on Cisco Talus's blog. There's some work being done, cat and mouse style, to improve the fingerprint reader. Every single time an attacker can work around one of these controls, the defenders, via hardware, via software, via anti-fraud techniques, can add more controls in to stop that fraud without affecting the user. People didn't have to get a new face when Windows Hello was using new cameras. without causing users to go, oh, you used to have an 8-character password, now you need to have a 16-character password, right? It's intriguing to me to move to passwordless because it really exemplifies our ability to add more layers and more controls that directly hit the path the adversary is taking without lessening the user experience. Really cool stuff. So here we're looking at number of steps. Certainly sitting down your computer and opening it up with a, Windows Hello, a couple fewer steps. Familiarity. There will be a training process involved. So for a while, it may feel less familiar for users. They shift to passwordless, but I expect that will, drop off pretty quickly. And if we can provide a very consistent experience from desktop to applications to legacy technology to web browsers, we can avoid running into familiarity traps, such as I was mentioning earlier, where I've got 4 different multi-factor authenticators on my phone. And finally, friction at each step. The trick here with passwordless is to reduce the friction for the majority of the users. So 60% of the people who are logging in, who don't have to worry about much risk at all. They're at home, they look at their computer, life is good. Well, giving us the ability to add friction if and when it makes sense to get in the way of the criminals. You are about to go from being on your desktop to being in the financial services application to transferring money. Good time to perhaps re-authenticate using perhaps a different factor to make sure the person is still who they say they are. So it gives us a lot of balance. Now, one of the interesting things about this is the steps the criminal takes. We've known in our gut for a long time, anyone who's done threat modeling or attack path analysis, that more steps causes bad guys to quit. We did not know how many steps we should target until last year Verizon puts out this report, and it's a fantastic chart. They did a great job where they actually looked at the number of steps and typical breaches, and they looked at the number of steps as it impacts the success of an attack. What they found is the magic number is 10. If you can have 10 steps in the path, the success falls to 50%. If you get to 15, the attacker's going to get caught. They're going to give up, or otherwise the attack's going to fail. So adding even a few steps along the path that the criminals are taking, being mindful again of how they're going to move through your environment, can directly impact the likelihood and severity of an attack, as evidenced by Verizon's data. So we want to add steps where it counts, being very thoughtful to balance the usability and defensibility. Just a quick note here: if you want to get hands-on with passwordless, keep an eye on Manning Publications. I actually got a call with them in a couple hours. We are starting a live project that I'm going to be heading up, which will be a several-week project, building a application stack using SSO, using passwordless, etc. If you're interested, shoot me a tweet or whatnot, or keep an eye on Manning Publications. I think we'll be looking for some beta testers. So you get to hang out, you get to build it, you get to see what I'm talking about. There's an option for you. All right, next example, trust, zero trust. So fundamentally, now that we've got such a rapid embracing of people working from anywhere, doing anything at any time, the idea of moving a control to where the user is becomes much more important. Our trust boundaries used to be what? Our networks, our data centers, our offices. Those are our trust boundaries. If you were in the office and you're plugged into my network and connecting through my network segmentation and some ACLs into my enterprise applications, I could trust you. I could look you in the eyes, and life was good. However, we don't necessarily have those levels of trust indicators anymore. We don't necessarily have the ability to look somebody in the eye anymore. We don't necessarily have the ability to use those trust boundaries. So we have to shrink the trust boundaries to where the users are and what they're doing. And I think that's what's exciting about zero trust. There's a lot of confusion sometimes around zero trust, what it is, what it isn't. But fundamentally, I think about those 1,400 cloud apps, I think about those users with 6 or more devices. I think about how do we implement a authentication and access control workflow for people accessing those things so that we can get them away from our sensitive data, get them away from our sensitive applications when we have cause not to trust them. From an architecture perspective, I think of zero trust as someone accessing something from somewhere. You got your user, they're logging in to a cloud app. You got your user, they're logging into a VPN to get to an enterprise app. Perhaps you have a piece of equipment that's logging into a network to communicate out to the internet. Perhaps you have a application service that's logging into a application fabric to communicate with other application services. Either way, you have an identity, you have a control, and we've got something they're trying to get to, right? The concept of zero trust is to reduce the trust of that access. We do that by running it through a policy engine. We do that by setting up a policy that exemplifies the things that we're concerned about, the things we want to allow, and the things we want to block. So, for example, I might only allow doctors to access medical records from devices that we know about, that we manage. Or in a manufacturing world, I may allow anyone to access most of our applications, maybe not the SAP system, but everything else they can access from whatever device they have, as long as it's up to date, not jailbroken. Those types of scenarios can be created and enforced. I want to let my manufacturing line equipment talk to my network and receive instructions and all the ICS SCADA goodness that goes along with that, as long as it's up to date and healthy and talking to things that I approve. So we got a policy engine, and to create decisions, to make decisions, you got some trust inference. And trust inference can be things like, is this user coming from a different device that we've never seen before? Are they coming from a different location they've never seen before? That one right there is a terrible one, given the current location and situation, but it's important if you want to look at geovelocity, right? I just logged in from Detroit, and now I'm logging in from Singapore. Are they accessing things they normally do? Is the behavior normal? Is the device they're on, is it up to date? I mentioned. Is it jailbroken? I mentioned. What about this? Is the device they're on infected? So if I try to access sensitive information, let's say I'm at a university, I want to log into Banner, I want to get at some student records. That's my normal job. But today my computer is infected. Well, clearly we shouldn't trust that connection. I don't know if that computer's got a command and control. I don't know if it's like commodity malware or if it's weaponized malware. There's a lot of things going on there. So until we figure that out, let's block that access. So the concept of zero trust is it allows us to step into that authentication workflow and make a decision based on a whole bunch of trust signals that exemplify these risky scenarios that we talked through, and then the other risky scenarios you guys are concerned about. When we think about this from a design perspective, I want to jump back to that overall life cycle, because as we build these things, it is imperative that it's thought about in different ways, right? So perhaps the vision is, hey, I want to extend the correct amount of trust to my employees and enable them to work from wherever, whenever. Perhaps the business goal is, hey, look, with what's going on right now, and everyone working from home, we need tighter controls. Or to secure and continue our digital transformation, our cloud first initiatives, we want to make sure we have good protections around that. From a security perspective, hey, RBAC is great. Roles, permissions, awesome. I love it. We've got that in place. That's fantastic. Do I still trust someone to go ahead and use those permissions? And now, if I don't allow them to trust it, how do I feed that into my other security functions? How does my SOC team know, hey, I need to jump in and do something? How does my vulnerability and patch team know, hey, wait a minute, these devices are out of date, right? How do we integrate this in? From a controls perspective, you're thinking about things like everything I mentioned, up to date, clean, good locations, anti-geo velocity. From a tooling perspective, this is where people get sick of the term zero trust, right? Because you don't want to talk about zero trust at that point in time. You want to talk about things like, hey, I want to have a really good adaptive authentication. I want to have a really good 802.11x on my network so that I'm doing the right things and protecting my devices. Hey, my DevOps team is going ahead and pushing out code. I want to consume those YAML files and enact a policy to make sure that the applications are only talking like they should, right? Tooling is very, very specific. And usually when we're at the tooling phase, we're just absolutely sick of the buzzwords, to be honest. And then, you will go ahead and you build your implementation plan. But as you think through something like zero trust, which is, a bit larger than the passwordless conversation, you can start to see that different folks are going to have different priorities and different emphasis. And the focus of the CISO on the business, the focus of the security directors on how the integration is going to work, the focus on the practitioner in terms of making sure it's good technology and easy to use and works, all will drive a successful design. Tooling is interesting too, right? Because we don't want to have too many tools. For a long time, we've known, hey, simple is better. It's not always clear how simple is simple enough. It's also not always clear when things get too complex what that means for everyone downstream. Have I just made your job a little bit harder or a lot harder? I don't know. I added 4 alerts and a new console. It's still a single pane of glass. You got one monitor, I suppose. I mean, there's those sort of conversations. So recently we did a study. We at Cisco did a study. It came out this week. If you want to download it, you can check out the whole thing. But the key point I wanted to pull out here was that downtime from a security incident. So a security incident happens and you've got to do, containment and get everything back up and operational. Downtime from a security incident is actually correlated with the number of vendors. So if you had like one vendor, you could probably get up in about 4 hours. If you had, dozens of vendors, your downtime is 17 hours or more. And I found this very useful data. Much like we never necessarily knew how many steps were too many steps for the adversary, now we before didn't know how many tools were too many tools for the security team. This is a great way to say, here's the line that we need to take. So we want to add tools, obviously, only where it matters and in context with the broader design. If you want to know more about zero trust standards, NIST put out 800-207. I was very excited when they did. I'm old enough to remember when RBAC first came out, everyone was up in arms about that. Like, oh, it's just hype. It's just those, they're trying to sell us more directory services. And then NIST came out with a standard that's since moved to a different standard body. And people, oh, okay, I get it. Here's the benefit. So in much the same way, NIST has standardized zero trust, still in draft. It's working its way through. You can go ahead and grab that. And there's also the National Cyber Security Center in the UK has architecture principles that you can go to learn more about zero trust. So with that, let's give some final thoughts, and then we'll open it up for questions. It's imperative that security be thoughtfully and carefully injected. Obviously, we don't want security that stops the users. And a lot of security professionals get that. There's about mid of the last decade, CISOs were like, we're no longer the Department of No. We're just going to ask people to slow down, and that's almost as bad. But we don't necessarily want to stop them or slow them down. Ideally, it's invisible. The best case, and this very rarely happens, but the best case is security that actually speeds up users. Passwordless may be an example of that. I've seen people who build application templates with all the controls in place that speeds up dev teams. There's certainly ways to inject really smart controls, well thought, well constructed, well designed controls that speeds up the users. But that's not to say we should never stop the users. It's not to say we should never slow them down. Obviously, when we need to add steps, we want to make sure that we're adding steps in a way that directly impacts the adversary. Ideally, disproportionately impacts the adversary. If it takes a user a second to do MFA, it takes an adversary, hours to days and perhaps longer to try and trick them or get around it. Unfortunately, our metrics are just not designed for this. Our metrics are old and stodgy. They're very operational, right? How many hits were on my firewalls? How many times did I see malware? How many alerts were in my SIM? How many patches are unpatched in my environment? We very rarely measure at the security capability level. We very rarely measure at the user doing the job level. And I think in part it's because we measure what we can and we forget that measurements are actually part of control theory. So real quick about control theory, if you think about, hey, we want someone to do something, we have a process, right? We want the developers to write clean code. That is our goal. We're going to put a control in place with that process. We're going to require them to scan the code and correct errors. Oftentimes we stop there and then we measure like, hey, how many times are we seeing bad errors? The fundamental concept with control theory is that you feed back that metric into the control itself. You feed back that metric into the beginning so that when things happen, new sprint, new code base, when things happen, everyone's working from home. When things happen, there's a disturbance that the control can give you guidance as to what you do. It's imperative that when we design our security capabilities, we use more of a control theory approach to put in place metrics. And then we can do something about it, right? I love the 4 I's approach to troubleshooting when the metric shows things are not going to plan. This was developed by Spencer Greenberg, but it came to my attention from Fernando Montenegro at Converge Detroit. So if you want to know more about this, look up his talk. I think it was a couple years ago. So first is ignorance. They just don't know. We asked the developers to write clean code, but they didn't know how. Or we asked users not to click on phishing links, but they didn't have the awareness of to identify those. So that's an easy one, right? You just provide awareness training, you provide skill building, those sort of things. Irrationality is intriguing. Effectively, I like to say that human beings are 3 cognitive biases in a trench coat. And what that means is we can have a great technology, but if we haven't taken into account the human factors, how they're perceiving the controls, how they're perceiving what we're asking of them, those sort of things, it's just not going to fly. So we need to think about iterating the design in this case. Perhaps it's the way we explain it, or perhaps it's the way we implement it. A good example here is passwordless, where people are concerned about biometric data. Is that a real concern? Is not a real concern? Certainly privacy matters, but also certainly we could iterate the design to offer them different factors so they didn't have to worry about that. Incentives is a good one. We've got an IAM function I was talking about earlier. We've got managers who are doing access reviews. We notice the managers, a certain pool of them are consistently late or don't do them. We've got to hound them and hound them and hound them. Well, we peel that back and we have a metric that shows what those managers are, and we can identify what's happening. Quite likely what's going on is they're incentivized to meet their quarterly goals. To meet their quarterly goals, they have to give a lot of time and attention to that, which means ignoring access reviews. So it's tweaking the incentives. And finally, investment. I've got a help desk who's resetting passwords, and they've got a identity proofing system to make sure it really is you. However, everyone and their brother has forgotten their passwords, and we're all logging in from different locations, and call volume is way high, and therefore people are skipping that control or bypassing it or not fulfilling it. So what do we do? Perhaps we invest in more people, add people to the help desk. Perhaps we invest in better technology. We put in place a password reset system. Those types of investments. If you think about this, there's 4 ways to look at a metric when the metric isn't going the way you want, and 4 ways we can act. And generally, 9 times out of 10, the only one we're using is awareness training. Well, we'll just tell them about it. We'll send them an email. We'll do this, we'll do that, right? When there really is a whole slew of different techniques that we can use to better align the security controls with the human factors to get people to do the right thing, especially when we make the right thing the easier thing to do. Fundamentally, culture is what we do and why we do it. Security culture, no different. So what I'd argue is creating a security culture starts with measuring the what and then moves to changing the why. Measuring the what is smart metrics and the capability, and changing the why is using that 4 eyes technique to guide the conversation to change the underlying assumptions of the user population. This is important, right? This is important. You may say, why design security? Why are we spending an entire hour designing security? And I'd say, because we can't afford the next decade to continue the trend lines that we saw in the previous decade. We just can't. We can't continue to afford this number of breaches. Our industry will not survive it. Our organizations will not allow it. We've got to do something different. We can't keep banging our head against the wall. Although, as I was putting the slide together, I was informed that banging your head against the wall does indeed burn 150 calories an hour, which is a good metric to have if you're concerned about the COVID-15, the weight we're all putting on in quarantine. So what I would like us all to do is design for usability by reducing friction and reducing effort along the paths that our end users are taking. Design for defensibility by increasing friction, increasing effort, getting in the way, adding steps, adding confusion, changing the parameters, right? Doing those things to get in the way of the adversary. The sweet spot, the art of cybersecurity, is finding areas where we can do both. Very rare, very hard to find. The key is looking. And from that key, we can effectively balance out usability and defensibility. I'm going to open it to questions in just a moment. I do want to say thank you guys. Once again, you can find me on Twitter. I also have a link here to my blog. I'm currently doing a weekly series exploring this concept where I look very closely at design and give guidelines. So, argue with me, challenge me. I'm going to open up for questions here, and certainly follow up with me if you want to know more. So what questions do we have?
Yeah, thanks for that. Got a few good questions here lined up. I'll start shooting them over to you. So one question we had are some of the policies for zero trust developed through machine learning?
Absolutely. So there's a couple different aspects of that. When I'm talking about trust inference, one of the very interesting ways to do that is to use machine learning on a UEBA, right? To know, hey, where do people usually log in from? What do they normally do? And not trust when that changes. So certainly that's an input. Duo has a feature called Trust Monitor. Other zero trust companies have comparable ideas, I'm sure. The concern you have to be there, where you have to be careful, is when things change very rapidly. So a lot of the people who are running UEBA struggled when everyone went from work from the office to work from home, because that created a whole bunch of false positives. The models need to relearn. So just be aware that definitely use it. It's good, but do be aware that when rapid change happens, there is a relearning and reacclimation process.
Great, thank you. And we got a question from Dan here. What happens if the employee is the adversary? How do you increase and decrease friction at the same time?
Oh yeah, no. Oh, that's a good one. Especially right now, because we're seeing insider threat on the rise, right? People are concerned about their jobs. They're concerned about a number of things. So the employee as the adversary, what you need to do is think about it in terms of fraud and add friction where fraud might occur. My go-to example for this is Amazon. I can buy stuff on Amazon all day long. They love taking my money. The boxes arrive. I still need to clean out my garage for tomorrow's trash day. However, I change my credit card or I change my shipping address, so then I need to log back in and use MFA. Why? Because those actions are consistent with fraud. So if you do threat modeling around an insider attack and you think about, prioritize it and think about the impactful things it might do, add friction on those steps.
Awesome, thank you. We got another good question here from John. Is what ergonomics concepts do you find most useful to guiding security design?
What ergonomics concepts? In terms of motion, so the concept of unity, the concept of consistency in motion, the concept of comfort. So as things get out of your comfort, it gets more painful, and therefore people don't want to do it. Those types of concepts I think are directly applicable. More broadly, when you get out of physical ergonomics and you get into the psychological study, this gets back to the two main points I hit on, which is reducing the amount of effort a person needs to take and a reducing amount of things they need to think about to get their job done.
Wonderful. Thank you, sir. Here's a good one. So with relation to the number of security products to the amount of downtime, what type of security incidents are you speaking to? Are these major events like ransomware or smaller events such as protected data events?
So in this particular study, we talked to, it was a double-blind study, and the researchers that we had engaged talked to people who reported they were doing security 50% or more of their time in organizations up to 499 people globally, and a very significant data set. So the question was related to downtime from a breach. So we don't have granularity as, hey, was that different between a ransomware attack versus a, someone accidentally turning something off? We don't have that level of granularity, and I think that'd be a great follow-up study. But certainly, I recall one time I was in my data center, and we were having a issue that I was trying to troubleshoot, and I sent my team out to figure it out. And my storage guy came back and said, "Oh, the problem is we're having too many IOPS on our SAN. We need to move everything to SSD right away." And my networking guy said, "Look, we're not getting much packets on the backplane, which means that we must be bottlenecking at the edge switches. So I think we need to reset all those." And my application guy's like, "Look, the issue here is that our application is not responding; it's timing out. So we probably need to restart all our web servers." And every one of those people had a different perspective based on a different console. And that was the outage ended up actually, it was the SAN, spoiler alert, but that's not the point. The point was I spent the first several hours just trying to get the entire team on the same page because they're all looking at different consoles and going different directions. So I think regardless of the underlying issue, fewer consoles and a unified view is always a simpler and more effective way to get things back together.
Great. Good tips. Thank you. So I think that comes up on time. There are a few other questions. So I see you have your email listed here for them. If you guys do have additional questions, please send them over. Any last minute comments before we close the presentation?
Yeah, those are some great questions. Please do follow up. And I really appreciate you guys joining. And I hope you have a fantastic time here at the rest of Secure 360.
Great. Thanks, everyone.